Hello everyone, welcome back to the Introduction to DevOps Engineering series. In episode 1, we talk about the DevOps mindset. In episode 2, we explored Docker and containers. And now it's time to connect the dots and take it up a notch. Today, we are talking about Kubernetes. If Docker helps you build and run containers, Kubernetes helps you manage, scale, and orchestrate them, especially when things get complex. Why Kubernetes? Let's start with the simple question. Why do we need Kubernetes at all? Imagine running an app with 20 microservices, each one in its own Docker container. Now imagine deploying it to production. What happens if one crashes, or traffic spikes, or you need to roll out an update? Kubernetes steps in as the automated operation system for your containers. It watches over your applications, restarts failed containers, scales them up and down, and helps you deploy updates without downtime. History and ecosystem. Kubernetes, also known as KX, was developed at Google based on their internal system called Borg. Google donated it to the Cloud Native Computing Foundation (CNCF), and it quickly became the industry standard. Today, Kubernetes runs everywhere: AWS, Azure, Google Cloud, your own laptop, Raspberry Pi clusters, you name it. Kubernetes architecture overview. Now let's break down how Kubernetes works under the hood. Don't worry, we'll keep it beginner friendly. Key concepts. Cluster. A Kubernetes environment made of master control plane. Makes decisions, scheduling, scaling, etc. Worker nodes. Run your actual application containers. Pod. The smallest unit. Usually holds one container. Pods are ephemeral. Deployment. Defines how pods should be created, updated, or rolled back. Service. Exposes pods to internal or external traffic reliably. Namespace. Virtual separation inside a cluster, used for isolation. Think of the control plane as the brain, the nodes as the muscle, and the pods as the workers. Kubernetes manages them all with precise control. Key features and why DevOps engineers love it. Kubernetes isn't just a buzzword. It's packed with powerful features that make DevOps life easier. Let's see. Auto-scaling. Kubernetes adjusts resources based on demand. Self-healing. Crashed containers are restarted automatically. Rolling updates. Deploy new versions with zero downtime. Declarative config. Define everything in YAML. CI/CD integration. Works seamlessly with tools like Jenkins, GitLab, and Argo CD. As a DevOps engineer, your job is to automate and scale efficiently. Kubernetes is your best ally. Real-life use case example. Let's walk through a real-world example. Scenario. You run a shopping app with a front-end container, a back-end API container, a database container. In Kubernetes, you'd create deployments for each component, define services to let them talk to each other, and expose the front-end to the internet. Kubernetes will ensure all components are running, auto-scale if traffic spikes, and roll back if an update breaks the app, That's resilience, DevOps style. Kubernetes in action. Basic commands. I am planning to conduct Kubernetes lab sessions in this channel in future. So today we are going to get brief idea about the Kubernetes in action. Let's look at a few basic Kubernetes commands you will use often. The purpose of first command is list all the pods running in your current Kubernetes namespace. So what happens? Contacts the Kubernetes API server, fetches and displays the status of each pod, name, ready state, restarts, age, etc. Helps you monitor what's running. The second one, the purpose is that command is shows detailed information about a specific pod. So what happens is queries the Kubernetes API for metadata and live status, displays events, container logs, volumes, mounts, resource usage and etc. Useful for debugging why a pod is crashing or pending. The third command, the purpose of that command is applies a Kubernetes configuration file. So what happens in this command is reads deployment.yaml file, send it to the Kubernetes API to create or update resources like deployments, services and etc. This is declarative configuration. You tell K8s what you want and it figures out how to make it happen. The last command, the purpose of that command is deletes a Kubernetes services. So what happened in this command is sends a request to remove the specified service object. The underlying pods still run, but they are no longer accessible to that service. Often used to tear down old service or replace them with updated ones. kubectl is your main tool to interact with Kubernetes. Most real-world workflows involve writing YAML files to define your resources and then using kubectl apply to deploy them. So let's recap what we learned today. Kubernetes helps manage and scale containers. Pods, nodes, deployments, and services are key concepts. K8s automates scaling, healing, and updates. Works perfectly with CI/CD pipelines. If you enjoyed this video, hit that like button. Subscribe for more. See you on next video.